So moving on to the next presentation, we have Ignacio Espinosa from JA Solar, who is a Senior Technical Manager. He's going to talk about solid quality is the key for solar module while entering high efficiency N-type era. Ignacio?
Hello, good morning, everybody. Thank you for the introduction. So I take the floor then for me. All right, I will share my screen. Should be this. Okay, so again, thank you so much for this opportunity to talk about such an important topic as the reliability for us, right? For J Solar, I have to say that it's one of the key points when we are designing all of our products and when we are launching new products and mainly new technologies. I will try to explain over the whole presentation, okay, why this is key for us and why we are happy to talk about this. Well, firstly, I will start with some insights about the company, but I will not stop in our numbers because I believe that everybody knows J Solar. I would just remark which of our characteristics it's really supporting and pushing the reliability of our products. In this case, these are general numbers, our global presence and so on, which are impressive numbers, but today it's to talk about the reliability. So let me remark the 140 gigawatts of accumulated shipments that we have achieved up to now, okay? Okay, this big volume of products which are working worldwide around in different environments, obviously they are also different technologies, but all of this information is coming back to our research and development department to still improving the reliability of the products. It means that we can analyze how these products are working in let's say in extreme conditions like extreme temperature, humidity, snow places, high wind places, and it is also it's always coming back to us to improve the materials that we are using to build the modules and ensure a higher reliability, because we should never forget that we are talking about products that will remain working for 30 years, and in 30 years a lot of things could happen. So definitely this topic, the reliability for all the technical guys around the products and the projects, needs to be a main topic, right? It is for us, and one of the things that it's allowing us to keep the reliability of our products is that we are vertically integrated, okay? We as J Solar, we started manufacturing cells, and it is the core part, the technology core part of the modules. And we have been always developing all the new technologies. For example, in our research and development department, we have over the table all the technologies that now could be building PV modules. But we, as J Solar, the philosophy of our company, it's just using the major technology which ensures a full reliability, okay? It's something that probably it's a disadvantage sometimes because we will not be the first one launching new technologies, probably, but we will be there when something is major, okay? So all the players that want to ensure this concept, they are probably sharing some philosophy with us, no? So, well, numbers of capacity, it's and speak for other days, but it's roughly this 100 gigawatts for next year. Our presence in Europe also as well, linked to the concept of reliability. I would like to say that we have a complete service team available in Europe to ensure, in case something happens, a good service for the customers. Our product portfolio currently it's compounded by some few PERC modules, okay, that will remain available for the following year probably, and it's likely to be also in the market for 2026. But it's, you know, that we are nowadays talking about the TOPCon technology, the N-type modules. I would say that it's the N-type era starting now. in our production of 95 gigawatts for next year, the 70% will be TOPCon modules. And well, we really believe it's a major technology nowadays, and it's the time for them in terms of also the economy wise, because there are other technologies like, well, heterojaction or even back contacts, but we don't think it's still the moment in terms of the evolution of those technologies and the cost wise, right? Which is this balance between the mass production capacities, the evolution of the technology, and the demand of the market. We have listened the market, and we feel that it's the end type era. Well, let's go directly to the reliability topic. How to ensure, right? How to ensure the reliability on our modules. Well, just a small stop here, because as said, this is a key topic for us, and we have been participated on all the programs around in the market to create this trust in the customers in the market, that, well, we are making great efforts in our factories. Now we need to transmit, to communicate. So we participate on these programs, and we are top brand obtaining the PV seals this year. Okay, you can see all the geographies where we have been rewarded, but the previous years as well, and other programs that I will explain later, okay, about the reliability of the PV modules. So we start this block directly. So how can we ensure the reliability? Well, there are two main ways in our view to control that. The first one is to control the whole manufacturing chain. It's the concept that I mentioned, to be vertically integrated. We have almost the same capacity on the cell part and the modules part. So we are really balanced. I would say that we would be probably the most balanced in terms of the capacity of production of the cells, controlling the quality and controlling the reliability of the cells, and the capacity for the PV modules, which are also elements inside the PV modules that are affecting the lifetime and the proper performance of the module and safety of the modules and during the whole lifetime, right? So this first step, we are there, okay? And it's really important because you can make actions inside your house, okay, to improve this reliability. Something that you detect in the PV modules are coming from the cells, then you act in some part of this chain. And the second one, which is the important one for the end players, for our customers, it's how to ensure this, because, okay, Jay Solar, you can say that you are making great efforts there, but how can I check it, and how can I prove it for the rest of the chain, of the downstream chain below me, the financial entities, the end customers, all the developers? So how to check it? It's through testing the modules, right? So for testing the modules, there are another two ways, no? It's like to meet the IEC standards, which are looking at these extreme conditions that the modules could be operating. And you need to pass this test, okay, which are regulated by IEC standards, and then you obtain your certificates, such as the salt mist, for ammonia, okay, for extreme chemical environments, dust and sand for these conditions of sand and these storms and so on. Dynamic mechanical load test, which is present in all the plants and all PV plants around, right? All these vibrations caused by the winds and so on. Salt water pressure immersion testing, it's also something that we have. LETID, which is a common effect known, okay, also regulated by the IEC standard, and of course the PID test. No? So all these packets of IEC standards, of course, we have it for all of our models. And another way to check this aging of the modules and the resistance of the modules is in a special test sequence, which are well known in the market. For example, the PVEL, okay, sequence, which is a really known program, okay, and the manufacturers, we are applying and sending samples there. Later, I will explain which is the sequence. Retech test sequence as well, it's also well known. And nowadays, there were released the ICTEs 63209, and this is quite common more and more nowadays, okay? So I will describe them with details later as well. So IC standards, as said, okay, salt mist corrosion, ammonia, dust and sand, we have all of them, okay, and the modules generation, performance, and safety will be proved according to the IC standards, which are regulating our activity worldwide through these certificates, okay? But if you want to go a step further, you will need to look for this special test sequence, okay? For example, the IEC 63209, it's a popular test sequence, which is combining tests that are present in this IEC standard to make different sequence of aging, of testing the modules. You know that we are using climate chambers. We are later doing EL tests to check how the modules are, the behavior against these conditions. Of course, power tests, stabilization tests. So it's sequence processes that we are doing under laboratories to simulate what could be the hardest conditions for the modules. This is something that I used to tell to the customers. We are testing here the modules in an extreme conditions, and depending on the environment where you are installing the modules, you may find better condition for the module, okay? Maybe it's something that will never happen, this result, but it's good because we are testing something extreme, so we will have more confident on the module aging, right? So this IC, it's including damp heat testing, thermal cycling, UV testing, okay, which is quite extreme for the modules, okay, humidity freeze test as well. And well, from our modules, from our side, of course, the PERC modules, they passed it a long time ago, but now all the N-type products that we have in our portfolio, they have also passed this test, and they are open for you, open for the customers. We can share it, then you can check which is the degradation of our modules. Later, we will see the results, but I can anticipate that they are below the 5% demanded by the standard, set it as the standard, this 5%, but even below that, okay, much below that. Later we will see it. The PBL program, it's also a popular test sequence. There is some detail here. I will not stop on them, but it's, again, including thermal cycling, damp heat. There are backsheet durability sequence, okay, interesting as well, combining different stress tests and for the modules. Mechanical stress sequence, the hail stress sequence, which is currently really important and relevant because, well, we all know that the glass thickness of the modules have been reviewed, and we are trying to reduce it, but keeping the same performance, right? I can confirm that our modules can pass the IEC, this hail stress sequence, okay, up to hail bolts of the 35 millimeters with the standard conditions of the IEC, despite of being thinner, okay, in terms of the glass. But it's a hot topic, and we have all the information, we can share it, okay? And this PBL program, it's also including PID and LETID test. There is a result, okay? There is like, they are carrying out all these tests, and later they are releasing an historical scorecard. Obviously, well, JA Solar, of course, we are in the top as a top performance on this test. I have to say that the N-type modules, the result is not yet available because these tests are taking more than 8 months. So it's almost a year to have it. So as we start to produce it recently, and you need to take some 13 samples from the production, we are doing this test, and we are really confident, according to the results that we have obtained of this single test, that we will be performing in the same level than our PERC modules as top performance for PBL. In terms of the RETEC, okay, RETEC reliability sequence, again, it's including a damp heat, 2,000 hours, humidity freeze, PID, but the double time of testing, 192, static and dynamic mechanical loads, thermal cycling 600, which is 3 times the IC, UV exposures, LETID, and in this case, well, as said, no, as I anticipate, the degradation that we are obtaining is below 2%, no, with the top performance in terms of the quality, reliability, and performance. So again, this information, it's public from our side, and we can share with you just to confirm that it's not us telling to the market we are reliable. It's third party confirming with really, I have to say, a difficult test for the model. This is going to the figures, okay, the numbers that we obtaining, and this is based on our new N-type models, okay. You can see different types of LETID, LID, PID, thermal cycling, damp heat, even reaching, for example, the damp heat 3,000 hours, which is even in not, it's not present in this special sequence tests. We are like going a step forward on this regard and obtaining similar degradation, as you can see, below 2%. The most stressed programs, which is the UV, the dynamic mechanical loads, the thermal cycles, and humidity freeze. When we do it 3 times, it's the only moment when we are surpassing the 2%, always below the 5%, which could be, when it's not could be, it's considered the standard in the industry according to the IC. But as you can see, all of our results in this test are below, not all, but almost below the 2%, okay? We are feeling so confident. It's the message that I comment in the beginning. It's a key factor, the reliability for us, okay? Probably not the most brave ones launching something, but I can assure you that we will be there if the technology is mature. And the last part of my today's presentation is talking about the N-type challenges, something that we are facing now in the market. It's not happening in our models. It's not something that we detected in our models, but in this industry, we need to look around and collaborate together to jump over the potential problems, okay? It has been detected, and probably you are aware of that, a degradation in a high temperature and high humidity test have been observed with glass-backsheet N-type models, okay? So the problem is that the EL results were showing a dark area in the edge of the cells, which was similar in aspect to some metallization degradation processes that we saw in the past that was caused by acetic acid generated inside the module, because we are not including this acetic acid in the module. No, it's coming from chemical reaction from other components. The cause is the encapsulation layers, like the EVA, they are easily hydrolyzed, okay? And if the mixture is penetrating into the module encapsulation, then the EVA films is becoming acetic acid through hydrolysis. And the resulting acetic acid will cause that the TOPCon silver aluminum paste corrosion will cause this undesired higher degradation, okay? Remember that this is coming from the encapsulation, okay, the backsheet modules. The solution is to keep on investigating encapsulation layers and improve aluminum paste, okay, to sort out this problem. I have to say that we have been working on this issue since almost 6 or 7 months, okay? And we are now more confident to find a solution. But now we are not manufacturing glass backsheet N-type models, only glass, where this effect is not happening, okay? So again, supporting this idea on a major technology, on being only in a major technology, it's that until the solution it's been 100% reliable, we will not be there, okay? We are just manufacturing glass. We are expecting that at the beginning of next year, the problem will be fully solved by this solution, changing the encapsulation layers and improving the aluminum paste. It's not changing the encapsulation layers, it's making modifications on them, okay? But the goal is to ensure the reliability of this glass backsheet N-type, and reinforcing this idea on full reliability for all of our products, which is key for us, and we believe key for the market as well. So that's all from my side for today. I would like to have more time to talk about this topic, but I think it's a good point also to share this.
Thank you very much, Ignacio. So I think you already answered a part of my question, because I was really interested because Lars started with this discussion glass backsheet module. So So where do you think the major concern is? So is it optimizing the encapsulation can yield a better result, metallization both?
Yes, definitely. The encapsulations, as I said, it's not a matter of changing the encapsulation. No, we really need to go to the point of the encapsulation, which is causing this creation of the acetic acid. And in the meantime, trying to reduce this moisture entering into the encapsulation. So basically, we are acting in all the points, right? It's also the aluminum paste, which is causing the acetic acid. But I feel confident. I mean, this industry, we have sorted out a lot of problems in the past, right? So and it's a pity that we need to find the problems to sort it out, but it's happening in everywhere, right? So yes, we are close to that, and mainly it's an encapsulation action, correct?
Right. So thanks a lot, Ignacio, for this great presentation. So it would be great. Please stay till the end, and if there are any questions, please try to answer in the chat box.
I'll do so. Thank you so much.
Thank you.